In Lesson B5, Linear and Nonlinear Functions. The standards we are looking at are listed here. The textbook, if you needed to look in your textbook, this is 4.2 and 4.3. So what we are looking at is that I can determine the best model for real-world problems. I understand that functional relationships and their distinguishing characteristics. What is the rate of change, the intercept, if they're linear or nonlinear. I can distinguish between linear and nonlinear functions and all representatives. So in the homework, you're going to ask to give your answer in a table, in a graph, an equation, and you will also see that it will say you have to do it in words, like in a sentence explaining it. So that would be like down here, the verbally. I can communicate similarities and differences in the different ways. You should have finished up and been asking while you were in your Zoom classes about the graphs on the previous assignments as you were looking at B4. And as we are looking at this assignment, first off, we're going to start with some vocabulary. A function is a relation that we are going to be looking at with pairs of inputs and with, we call them, exactly one output. So this is going to be key. One input, exactly one output. When we talk about our different functions that we've been talking about, a linear function is one who, when we take a look at the graph is going to be a straight line. The table is going to show repeated addition or subtraction. The equation is going to be y equals mx plus b, where it's our rate of change plus our initial point. And when we are taking a look, if any function is not linear, it is called nonlinear. So when we are looking at these different functions, if I look at this, a straight line means it could be a horizontal line. That's going to be an equation where it's y equals just a number, like 2. It could be a slanted line. This is going to have a positive value for m, or positive slope. And it could be a negative slope. Keeping in mind that as you're looking at these, so if it is not linear, it would not be a straight line. So it might be a curve, something like this. It could be something like this. It could be our absolute value functions we're going to be looking at. Could be something like this, or going down. Keep in mind that it could be even a broken line as we are looking at it. So as long as it's not straight, when we look at the equation, notice that this equation, whenever it is linear, that the variable x is to the first power. So when you are looking at equations that are nonlinear, you might see an x squared, you might see many different things where it's not to the first power. And in a table, if it's nonlinear, so we kind of talked about what linear is, that constant adding in the y column. And in a table for nonlinear is that you might see it's multiplying, or there's different patterns that you're looking at. As you look at this next page on your notes, it says determining a function is linear. The table in the graph shows the relationship between the number of photos that you're taking, so how many photos and how much memory is left on your memory chip. So the first question that we are looking at is this a function? Meaning, does each input on this give us one output? And we would say this is definitely a function. And again, if you need to pause this while you're working, yes, because for each number on the photo you take, there is only one amount of memory. Is it linear? And at this point, it kind of looks like it has a constant rate of change. Before we answer this question, we might want to take a look at the table. So they give us 0, 5, 12, 1, 509. So notice that our photos are going up by 1. We started with a memory of 512 before we took any pictures. And now it is going down by 3 each time we take a picture, which would make this a very linear function. So yes, the graph shows a pattern of a straight line. The table shows a pattern of repeated addition, adding -3 to the y column each time. Again, if you need to pause. As we look at problem 2, and again, as we are looking at yours, we should right now be on the top of page 13. So if you're looking at your notes, this is on the top of page 13. It says, determining if a function is linear. The pattern below is a function that represents using an and that we're asked to represent using an equation and a graph and determine if it's linear. So we have 1, then we have 4, 9. So the picture number is 1, we're given 1. The picture number is 2, we get 4. 3, 9, 4, 16. So first thing you're going to do is we are going to graph this. So at 1 we had 4, or 1 we had 1, excuse me. 2 we have 4. 3 we have 9. So if we are looking at this, please plot these points. So you should have these points. And someone said, well, what if we didn't have a figure? Remember, if you had 0, the area is 0. So thus this point right here. Not really part of ours, we really started here. So first thing we're looking at is we're trying to think, is there an equation? Now it's not going to be in slope-intercept form, but what are you doing, like we looked at in our first lessons in B1, what are we doing to this first number to get the second? And each time you are squaring it, so if you didn't recognize that, y equals x squared. And this is definitely, because it's x to the second, non-linear. So x to the second, not a first power, and we can look at our graph and the graph curve, so that would also make it nonlinear. So if you're asked to give a reason, you could say the equation is not to the second, there is not constant addition in our table, or the graph curves, it is not a straight line. As we look at the bottom of this page, page 13, and you are taking a look at displaying functions, it says in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent it using a table, words, equation, and graph. In your homework, this is what you are doing for questions 1, 2, and 3. For 1, 2, and 3, the first 2 we give you a table. We don't give you a graph, so you need to draw the graph to the side. You're asked to give an equation, and then you're asked to give this in words. So if we are starting this off for 1 rectangle, 2, 3, and 4. And my hint is I would always think of the 0 rectangle. Now, again, the 0 rectangle isn't going to have perimeter, but it is going to give you a starting point, calling it our y-intercept. So if I was looking at rectangle 1, what is my perimeter? Well, we have 6 plus 1 and another 6 plus 1. Our perimeter is going to be 14. As we move to rectangle 2, you still have the 2 6s and you have the 2 1s, so we still have 14, but now it's kind of like we added one more side, so we are at 16. Take a look at those next 2 and make sure you check for the pattern and try and write these and also plot your points. So what do I mean by plotting your points? At 1 we are at 14. At 2 we were at 16. And plot the rest of your points, and then we're going to pause the video and then we'll come back and you'll see what these look like. Hopefully you were able to fill in the rest of your table with 18 and 20 and you graphed. One thing with your graphs, we are going to be asking you to label. So this is our x-axis, but that stood for our rectangles and our perimeter was on our y. And again, if we think of 0, so I noticed that this is linear already because we are adding 2 each time. And if I wanted to go back to my 0, I'm going to take 14 and I'm going to subtract 2. So if I was going up, that would mean 12. This is going to be nice for writing my equation. Because remember, we're trying to write our equations in our slope-intercept form. So if we are looking at it, what is our rate of change? That's the plus 2. And we started at 12. So our equation, y equals 2x plus 12. If we are looking at this, we are going to say that this function is linear. Now, the only thing that you see that we did not do here is we did not describe this in words. So if I am writing this out in words, as I do that, I just want you to be aware that my writing, you might have a harder time reading it, but if we are looking at this, when we were going to say our pattern, we might say something like, as the rectangles increase by 1, the perimeter increases by 2, and we started at 0, 12. No rectangle, imaginary 12 perimeter. As you look at this next page in your notes, we are on page 14. What you are asked to do is tell if it is linear or nonlinear. And in your homework, this is our last page of our notes today. In our homework, we ask you, after you tell us linear or nonlinear, to then give us a reason. So I'm going to do the same thing here. I would like you to pause the video and please try and go through and look at each one. And then you're going to see that I will have the answers for each. And then you are going to be asked to explain why. So you can see at this point that I gave you the linear or nonlinear. Now the reason. Here, what is happening is we have constant addition of 3. So my reason might be adding 3 as a constant addition. As I look at this one with being nonlinear, I might say because we added 2, then we added 1, not constant addition. The 2 on the bottom, the 2 nonlinear, not straight lines. And even though you might take a look at this one and say, well, this side is a straight line and this side is together, it is a V shape, so it is not a straight line, would be a good reason. And again, as we are looking here at our linear, we are subtracting 11 each time. So constant, if we are looking at that, adding of negative 11. So making sure in your homework, that second page, that you also give a reason. So the last page, we're comparing our functions. So when I take a look at this one, it tells me that we started in April, wants to charge her smartphone and tablet. Her smartphone already has 25% of the time she is starting to charge it. It takes 20 minutes to charge 10% of their smartphone battery. Her tablet is already charged to 18% at the time she is starting to charge it. And it takes 12 minutes to charge 12%. So you can see this table. As we are taking a look, the phone, we're talking about our minutes, 0, 20, 40, 60, 80, 100 minutes, and percent that our battery is charged. If we are taking a look at the tablet, we have minutes and battery charge. Now, here's the key thing when we are taking a look at this, is that you might want to think of this as the change in your battery. Change in battery, if we think of this as X and this is Y, minutes and Y, the change in battery means that we're subtracting 2 of our Y coordinates if we are looking at those. So how much is it changing each time? Divided by the change in our minutes. So here I can see that this is going up by 10. So it is going up by 10% for every 20 minutes of charging, which means if I'm dividing that, that comes out to be 0.5% per, if we are looking at it, minute. If I look at how fast my tablet is charging, when my tablet charges, again, the change in the battery percent is going to be, if we are looking at it from 18 to 30 per minute, if we look at this table, this is 12% per the change in our minutes. Well, the minutes go from 0 to 12. Oh, that's 12 is the change. That comes out to be 1% per minute. So if we are going to compare and contrast this table, a couple of things. You're going to be asked in your homework to give some different reasons on the test and on our quiz for this. So if I was looking at this, I just want you to look at some of the different information and how we wrote this. One of the things we could say is that they're both linear. They have a constant rate of change. At 0 minutes, one was at 25%, the tablet was 18%. That's our y-intercept beginning point. The phone is charging, if we are saying in this one, 1% per minute, and that would actually be our tablet. So that tablet is charging faster. The tablet is charging faster at 1% per minute, and the phone is charging slower at 0.5% per minute. So making sure you understand these and to be able to make a graph. You then turn back in your workbook, and as you turn back in your workbook, you are taking a look at this assignment. As you are doing this assignment, this is where I was talking about questions 1, 2, and 3. As you are looking at this, you are back on page 36. No, excuse me. You are going to be on page 34 and 35. So this is page 34, and this is your page 35. 35, you're going to tell us linear or nonlinear for each one and give an explanation. On this page, you need to have all 4 of these forms. So you need to fill in the table. Again, think about the 0 one. That might be helpful for you. 0, what should the perimeter be? Fill in the blanks. Give us in words what is happening as you increase the rectangles by 1. What's happening to the perimeter? That's going to be my words. You're going to write an equation. Again, thinking of that slope-intercept form, especially if it's linear, that we should be able to write it in this form. And then you need to make a table or a graph. And again, remember when you make your graph, you have your y and your x-axis. Please give us a title or a label so I know what are the words that you are using here, and then just do a rough sketch of your graph. Good luck. We'll see you in our Zoom session.